Sebastian and I like to talk about nice, I will say, not a really application user case. It's more practical from our standpoint. So it's more, let's talk about the sensors, right?
Yes, sensors and maybe also signals, trends, some trends. And we have also a case study with some real trends, but we will see.
Okay. Yeah, and I look to that, and we talk about the Hyper application, the Hyper machine.
That's correct.
And Hyper is not really a classic reciprocating machine. So we learn from day to day. We learn as well about these machines. Yeah.
Every day new experience.
Yeah, like this one. And so thank you so much that you share that with us, your experiences.
Yeah, you're welcome.
And I think let's start.
This case study shows the specialty of Hyper monitoring. We will have a look to the compressor in general overview, in detailed cylinder vibration, cylinder and plunger, and we will have a look to the Bars tube effect. What is this and why does it occur? And I will explain the library test where we checked the influence of temperatures that affected the measured values. We will also have a look to the experimental setup and to the results. Afterwards, example pictures of parts that causes the Bars tube effect will explain and show. Here we see the complete Hyper machine, in this case 12 cylinders. We have different parts like central valve, plunger itself, intermediate crosshead, the crankshaft, the crosshead frame, also the elastic rod coupling, and the packing and the cylinder itself. Which sensors are located on the Hyper compressor? We have for sure the trigger, which is very important for our monitoring system. We have also frame vibration and crosshead vibration, the cylinder vibration, and also the dynamic pressure sensors. In case of a Hyper compressor, it's the DMS rings. But in our case, we will have a special look to the plunger position, which is monitored with a proximity sensor. Here again, a sectional drawing from the Hyper compressor, but in the next slides, we will have a detailed look only at this area here, so the cylinder itself. The cylinder, it's with many parts in it, but we have a detailed look to the plunger, to the packing, and for sure the proximity sensor. The proximity sensor, one of these proximity sensors is located here. This is Y probe, and also the X probe is located here in this area. We have in mind that the plunger is going forward and backward in this packing because it's a dynamic part. This is really important to have in mind because this part, the plunger, could heat it up and the sensor will monitor in different areas of temperature. So what is the Bars tube effect? The Bars tube effect is so-called because it looks like a Bars tube. So we have here the proximity signals in our online diagram. Looks like a Bars tube. We see also cylinder vibration, crosshead vibration here, and also the dynamic pressure. But important is these signals from the proximity sensor here, the green and brown one. So in case of a malfunction in the packing, it could lead to partial heating of the plunger. So it's so-called a hotspot. It's shown here in this picture. This red area is the hottest one, and for sure the blue areas here, it's cold. But you have in mind, the plunger goes forward and backward in the packing and in the machine, and the proximity sensors measured the distance in different areas of the temperature. So a library test was performed, and the library test execution was like following. The distance between plunger and sensor was set to 1 millimeter when the plunger was cold. Then plunger section, in this case was wolfram carbide, the material, was heated up to 380 degrees Celsius. When temperature was cooling down, the distance and the temperature was monitored permanently. So we have the cooling phase and also the distance between plunger and sensor. Afterwards, we changed this diameter of thermal expansion and compensate it to our measurement. Here we see the results of the library test. We could see green and white line here. This is values from the proximity sensors, 2 different proximity sensors. We have the red line. What is the temperature in this area? It goes from 330 degrees Celsius to more or less 40 degrees Celsius. We have a maximum value from the plungers, from the proximity sensors, from 0.4 millimeters. And we compensate this delta L here, and we have a temperature influence from approx 0.1 millimeter per 100 degrees Celsius. Let's have a look to a real case study. So means we have a real case. We see here in our trend values the plunger peak-to-peak values in red. And we see in blue the plunger temperature. We will have a focus only to one of these peaks in this time. So here. Here you see the machine was stopped and started directly. Also important is no parts were changed in between these start and stops. 2 days before the event, we could see a slight increasing of the cylinder vibration in this area from 3 to 6, from segment 3 to segment 6 here. This was the first indication of something. At that time, when the event occurs, we have high temperature, and this high temperature leads to this, you see it here, the typical bath tube effect. So this brown and green, we saw it before in the slides, occurs because the temperature of the plunger was high. After the event, when the hypercompressor was started again, we have an increased cylinder vibration, which causes, in this case, by packing failure. But what we also see is, because the temperature was cooler than before, also the bath tube effect is gone, and we have a smooth movement from the plunger, here in brown and green. These are parts of the packing and what causes the bath tube effect. We have polymerization or maybe a malfunction from the packing, what is heated up the plunger, and when we have this hotspot on the plunger, it could be indicated with our proximity sensors with this typical bath tube effect. These are also parts which can lead to a bath tube effect or also to the vibration we see before. We have broken parts or maybe also polymerization in the packing.
Yeah, we welcome you. Thank you for listening to our web session, a case study point here, and have a great day. Yeah, see you next time. Bye-bye.
Also from my side, bye-bye.